Good morning, everyone. So today, what we are going to see, we recently came across new AWS interconnectivity news, right? So how we can work around the AWS and GCP interconnectivity with the new things, like how we can create or any applications or any microservice deployment through it. So I want today the infrastructure should be work around the Pulumi. It's like I want one small Node.js application deployment, microservice application deployment across AWS and GCP on Pulumi infrastructure. So let's jump in and see how we can work around it. So we'll create from scratch. We need to go here, the workspace, starting from scratch. I just want to give name like Node.js microservice CI/CD AWS GCP. Okay, so this is for our understanding. Description we can give anything as per our understanding. Then we need to make it public as a visible, so you can see my repository. So this is what I already created one prompt for this. It's like a generate a production ready Pulumi Python project that deploy a small Node.js microservice architecture across AWS and GCP interconnectivity using a new AWS interconnect feature. Include secure by default networking. So we are using here a by default networking for the demo purpose, like private subnets, AMS encryption, less privilege, IAM services account routing, cross cloud failure, logging monitoring, drift detections, validate all prerequisites and hidden dependencies, produce a complete folder structure, usable components, environment stack, CI/CD templates, doc and Pulumi best practices for config and secrets. So this is how the prompt is for our infra code based agent. Let's see like how it will create. Yeah, so it started creating the task. It's yeah. So all over, like there are 14 tasks it's working around. It's first setting up the Pulumi project structure with the Python and multi-cloud configurations, because we are going to work around the AWS and GCP both in a same directory. So this is what it's create a reusable components for AWS infrastructure, VPC, subnets, and security groups. Then components for same reusable components for GCP infrastructure, VPC, subnets, and firewalls. Yeah. So then it will implement AWS interconnect transist gateway for cloud cross cloud connectivity. Then configure KMS encryption for both AWS and GCP. Set up a list privileges, IAM roles, and a GCP service account. Deploy Node.js microservices to AWS ECS and GCP Cloud Run. Configure cross cloud failure and routing with health checks, implement logging and monitoring with the CloudWatch and cloud operations, set up a detections and compliance monitoring, creating the environment specific Pulumi stack, dev stage and prod. Yeah, this is what then generate a CI/CD pipeline templates for GitHub actions, then compressive documents and architecture diagram. Yes, so this is the interesting part, like architecture diagram for multi-cloud infrastructure. I'm going to show you that as well, because last video I have missed it. So I just wanted to show how it will create architecture diagram for the our projects here in infracode base. So yes, so setting up the first folder structure it has created. Now you can see here, yeah, components like AWS GCP and shared like encryptions and everything, the configs and docs, microservices, API gateways, notification services, order services, user monitoring stacks, and scripts. This is what we're having, this entire folder structure for our environments. If you see, the requirement should be like that. It's performing one task. Meanwhile, we will see the code like requirements, like see this kind of requirements like Pulumi, AWS, GCP, Docker, AWS X, dot environment, and the cloud storage, cloud monitoring. Pulumi YAML, yes, Pulumi YAML got created microservice for multi-cloud. Runtime on Python, production ready multi-cloud Node.js microservice on AWS and GCP. Pulumi templates for deploying Node.js microservice on across AWS and GCP. The region, like by default regions we have taken, so US West to default, it's coming around it, and default US Central one. Yeah, and the environment should be dev staging prod, and default environment is dev. So this is what the .git ignore file generated. Yeah. Then the stack, the staging stack, production, then development, the scripts, monitorings, microservices, API gateways, notification services, order services, user services. It's taking a time to generate, so it will work around one task. Now this KMS encryptions for both AWS and GCP got completed right now. Now creating the AWS IAM and ECS components. Okay, specific infrastructure components for AWS. I am yes for I am and ECS components which got created for AWS. You can see here AWS IAM components with lit privilege security models. This is exactly it's working around all codes. Yes, the ECS, then I am the network policies. Yeah, transit gateway for Pulumi component resource. And the important thing is like yeah, security group, application security group for application load balancer, HTTP port for 82, the CDI per block. Yes, HTTP and HTTPS both. Yeah, it's using a default networking, default security practices to create an infrastructure around a Pulumi using a Python code. Yeah. So this is what, typing a Pulumi, import from Pulumi AWS as a AWS. If you see for GCP, the same, it's generating init.py like it's network policies. You can see here, and the IAM policies. Yeah, this is basically working around all components on AWS as well as GCP. Like any cloud migration or anything is a requirement, like we need to deploy any microservice application on AWS as well as GCP using a new AWS interconnect policies or the thing, we can work around it as well. So a solid blueprint for our small microservice deployment. So it's generating one task for one, like, yeah, now it's creating a GCP infrastructure components. Now these many seven tasks got completed. Now it's on cross cloud failover and routing with the health checks. So sometime logging and monitoring with the cloud watch and cloud operations, set up the detections and compilers. So yes, it's creating a cross cloud failover and monitoring components. We'll see here monitoring stacks or any scripts, no stacks. So for dev, prod, and stage, for GCP for shared, yeah, multi-cloud infrastructure components need to be created. The encryption.py file for our project is here. This is a failure. Mm, this is exactly what we are going to see today for like AWS GCP interconnectivity. Let me create the monitoring and logging. It's going to create now. So wait for it. which makes sure the launching and logging. So running a script, task in progress. There are almost 7 tasks got completed. Now it's on a eighth task. Now they create the dip detections. Yeah, now it's creating the dip detections, compliance monitoring components. Now almost 9 tasks got completed. Specific Pulumi stacks. Yeah, this is what I wanted to see, that how it will create a stack for dev, prod, and stage for this AWS and GCP interconnectivity. And there's the thing is specific Pulumi stack like generate CI/CD pipeline templates for GitHub Actions. Yeah, CI/CD here. And the last one is compressor documentation and deployment guide that will generate, and it will generate a architecture diagram as well. So we will see that architecture diagram as well here. Onto the components would be AWS GCP and shared cross cloud. Config should be like settings.py, like what we are having in settings.py, like projects, config project name, config environment, Pulumi, and architecture for all the multi cloud. Okay, and the configurations like yeah, it's good actually. Setting in the multi-cloud deployment provides environment-specific configuration and validations. Yeah, basically, yeah. So it's now generating environment-specific Pulumi stack. Okay, so you're able to see right in the dev in the stack itself. We're having this dev in a dot py. It's generating a stack here. Pulumi.dev YAML got generated. Config you're able to see on dev central one, your GCP project, and microservice multi-cloud. This is our project name basically. And for production also the same Pulumi prod. You can see the environment prod, US West 2, and for staging US Central 1. So it's generating like the stack. Now it's generating the CI/CD environment. Mm, wait for the CI/CD environment components. Running a task, writing a run write, running a write, generating, create a compressed documentation and deployment guides, create architecture diagram for the multi-cloud infrastructure. So yes, created main.py. The main thing ECS cluster, GCP, VPC network, service accounts, then IAM policies, cloud run services, transit gateway, cloud VPN, GCP cloud VPN, and cross cloud failover, ECS ALB DNS name like zone ID, and everything we can include here like monitoring stack, trip detection, security compilers. So this is the main.py file for our project. All services like main deployment functions are like that, like encryption keys, if the AWS VPC network, AWS IAM role, there's ECS role, and rest we have seen. So now let's see the CI/CD GitHub action workflows got created infrastructure.yaml for this. This is what the GitHub actions it has created, and see around this infrastructure.yaml, and the same for the microservice YAML. Yeah, deploying to the staging environments. This is what like GitHub actions. microservice CI/CD branch main develop microservice main microservice service to deploy all API gateways, user services, order services, notification services. Then descriptions to environment GitHub actors secrets.github detect the changes services Ubuntu latest running on Ubuntu latest. Okay, yeah. Build and test, build Docker image. So this is a GitHub workflow for the CI/CD. It's now generating a compressive documentation for a deployment. It's a deployment guide. So wait for it. The main part I wanted to show you the architecture diagram for it. How Infracodebase is generating a architecture diagram after everything setting up. I want to see that deployments.md. Okay. Mm, the all folder components are there like CI/CD components, config, docs, microservices, monitoring, scripts, tags, main.py, .gitignore, pulumi.yaml, and requirements. And in the docs, deployment.md got created, and this is the everything is a compressive document for deployment. Is the deployment guide, how we can deploy that service using this documentation. We can easily work around it by changing our configurations as per our need. Like we need to just change the configuration, tokens, secrets, and everything, and we are ready to go for production as well. Now it's generating an architecture diagram tools for it, the diagram. And this is the readme file for it. If you see the readme file, suppose the project is licensed under MDI license, like please see the contribution.md for the guideline like code style and standard testing requirements for request. Yeah, it's diagram. Now it's diagram dot generated, and you can able to see the diagram perfectly. You see here multi-architecture diagram for AWS as well as GCP. AWS, GCP KMS, AWS KMS encryptions like AWS GCP, GCP VPC Route 53, AWS VPC. The tree, if you are going to see the tree here, KMS, AWS VPCs, branches, gateways, and then these all flows. It's going to show how it's working around the global load balancer. If you see, then application load balancer, API gateways, API gateways for the global load balancer, application load balancer, and this is the order services, user services, and this. So this is basically this kind of architecture diagram. It's working around like how the best practices it's using. It's the tree. It's layered. You can see here for global load balancer APIs. Then application load balancer for the cloud watch, then cloud operations. This is the basic workflow, how it's working around it. This is what it's going. Can see. So yeah, we see this is what I'm showing. Now we can see the code we need to push into our GitHub repo. Okay, so this is the repository name. We have added Node microservice AWS GCP description, and it's a public. So just create a repo. Now connected and link. Now just come here into the GitHub. We need to find out the repository. Uh, a repository got added. Before it was 117, now it's 118. So our Node microservice CI/CD AWS GCP repo got added and it's automatically pushed into the GitHub. You can see all code, the Infracodebase agent commit to was committed 1 minute ago. And here the code, entire code we wanted to see, like this is what like the readme file for this, the project structure, architecture, and like here in the docs we are having this deployment.md as well, the prerequisites for tool installations and everything, then cloud account access like AWS GCP project list and required API services, secret configurations, GCP service accounts, environment setup, and everything in the deployment guide. So long deployment for just deploying a small Node.js microservice applications on AWS and GCP interconnectivity. It has created entire infrastructure using a Pulumi Python code. So this is everything. If you see the project summary, this is what the project delivers the production ready multi-cloud microservice architecture using Pulumi Python that deploys Node.js application across AWS and GCP with enterprises grade security monitoring and automation. The complete deliverables like infrastructure as a code, Pulumi Python project, reusable components, environment management and configuration management, multi-cloud infrastructure, VPC network, ECS Fargate, application load balancer, transit gateway, and Route 53. This is what VPC networks, cloud run, global load balancer, cloud open, security first architectures like encryption, network security, identity management, VPC connectivity, and all like AWS compilers, AWS config, guard duty, security hub and integrations, audit logging, cloud trail and cloud logins. The cross-cloud DNS failover, traffic management, health monitoring, load balancing, application load balancing in the both clouds. Yeah, we see in the architecture diagram, right? So this is the basic project structure for this microservice multi-cloud. And this is what we're having for entire projects. This is the readme, and this is our entire projects, like project structure from microservice to cloud, and everything is here. The architecture should be like AWS on US West 2 and GCP on yes, and VPC interconnect. If you see failover Route 53 DNS ALB here for application load balancer, global load balancer, private subnets, ECS services, cloud run services, VPCs. Yeah, and configurations, Pulumi configurations, security features, and everything like metrics, dashboard, AWS Cloud or GCP Cloud operations, alerting, critical alerts, notification channels, logging, and deployments environment like feature brand, pull development, staging, and production. So this is what we're having basically. Only one branch got created, an entire infrastructure, Pulumi infrastructure got created using an Infracodebase agent. So you can see here. The code should be in a Python, Shell, Docker file is there, and JavaScript languages we are able to see. It's not anything like we have added any configuration, so I don't know how it will work around the access. But that GitHub workflows also got added here. So if we just need to give that configurations here in our infrastructure.yaml and microservice.yaml, so it will work around that GitHub actions as well. Yeah, yeah. This is what we're having for today for this, and this is the entire architecture diagram seen. So this is everything. If we go here in the dashboard, this got created. You can like these workflows. I just wanted to show you that AWS and GCP interconnectivity. So for that reason I have uh, created this demo video for AWS and GCP interconnectivity as a demo. Just a simple deploying one microservice application around it. I just wanted to cover this all topics like adding a tool, then workflows, and adding a rule set as well. And we will see one by one in the next session. So till then, thank you so much. Yeah, bye.